Hey there, how y'all doing? How many Texans in the room, right? Because we're in Austin, yeah, right on. So we're all Texans up here. Welcome to Texas if you're not from here, right? So we're excited that you're here in this room talking to us about Zero Trust. We're going to be talking Zero Trust. If you build it, they won't come in, right? So how do we keep the right people in our environments doing the right thing? So one of the big misconceptions and mythologies around Zero Trust is that it's only about identity. So I'm John Kindervag. I'm the field CTO for Palo Alto Networks, and I am the actual person who created Zero Trust. So I feel like I know a little bit about it. And that mythology that it's just multi-factor authentication, and that's all you need, and it's a product, and you buy Zero Trust, that's not true. That's a lie. And so what did I do? I brought in the world's top expert on identity, or at least one of the world's top experts on identity, my good friend, Eve Mailer, vice president at Forge Rock. She also worked with me at Forrester Research. She is the person behind most of the identity standards that you have dealt with. So she co-created XML, she helped develop SAML and OAuth and OpenID Connect, and now she's working on UMA, Unified Managed Access, which is like identity squared. So she's going to be talking about Zero Trust identity and how this all works together in the real world, okay? So I'm going to be just opening this up on what Zero Trust is, and hopefully this, there we go. So we have this idea of a trust model, and I'm sorry for the ringing in the microphones, but maybe somebody can pull that down a little bit. So we have this idea of trust in the environment, right? We have the idea that there's a trusted network and an untrusted network. And of course, the trusted network goes to the evil internet where all bad things are. And then you have the the trusted network, right? That's our good people, our wonderful people who have been authenticated. They will ride around on rainbow unicorns and give out candy to little boys and girls. That's how wonderful they are. And so we have built this entire trust model about enforcing this idea. Now, we know that bad things can come from the evil internet, and they can occasionally get to the inside of that network. What happens when we see that? What happens when somebody gets to the internal side of the network? We elevate their privileges. We give them this stuff called trust. What do they have to do to get that trust? They just have to get their packet on that physical segment. What is a packet? A packet is a collection of zeros and ones represented by electrons or photons. So if I can get my electron on the other side of this boundary, you're going to give me attributes of trust? That's insane. So that's where Zero Trust comes in. Now, we have this idea that we can enforce this trust model, but you have malicious insiders. You guys have heard names like Snowden or Manning, right? So if we look at this model, we're trying to get rid of the Snowdens, the Mannings, and all of the packets that are going to do bad things, because this is about packets. So people are not packets. I'm not saying people are not trustworthy. I'm saying people are not packets. No person has ever been on a network, and it is the anthropomorphization of the network that's killing us. So when we talk about identity, we're talking about the asserted identity of a human being who logs into a device, and that device actually generates the packets. This is all about packets, not people. So how do we think about this, right? Because you have people out there saying Zero Trust is just about identity, and identity is the new perimeter, and that's not true. Zero Trust is not identity. In fact, Zero Trust is not a product. If somebody says to you two things. One, if they say, oh, the goal of Zero Trust is to make a system trusted, that means they don't understand Zero Trust. And if they say, we have a Zero Trust product, it means they don't understand Zero Trust. There are no Zero Trust products. There are products we use to build Zero Trust environments, and we're going to be talking about that today. But you need to understand that this isn't just something you buy. It's something you do. It's a movement. So let's look at this guy, Edward Snowden. How many people have heard of Edward Snowden? I hope everybody in the room, right? Famous person who started a big data breach. Well, let's look at Edward. He had multi-factor authentication via a common access card. This is a PCM-CIA card that is used in the federal government that has a digital certificate on the card. This is multi-factor authentication at the highest level that you could have multi-factor authentication. What else did he have? Oh, he was on a trusted device. It had the right patch level, the right antivirus. He was allowed to create SSH tunnels with self-signed keys. And he utilized self-signed keys inserts to encrypt data and exfiltrate it. If multi-factor authentication, if authentication was all we needed, this guy would have been stopped. But he wasn't. So we need to go beyond that. Now, when I was at Forrester, I created something called the Data Security and Control Framework. How do you think about data? You have to think about data in new and unique ways. You need to define your data, discover it, and classify it. You need to dissect it, gather intelligence about it, and then analyze it. But mostly, in order to defend your data, there's only 4 things that you can do. You can control access to the data. You can inspect that access as it's happening. You can dispose or get rid of the data. Or you can kill your data. You can encrypt it, tokenize it, or mask it. That's it. There's only 4 things you can do. You can buy 3,000 different products to do that, but you can only do 4 things. And how you set those dials determines how secure you are. Zero trust is all about controlling access and inspecting access at the same time. So when you look at this, I released a couple of weeks ago on my blog, Thought Bubble, a blog post called All Layers Are Not Created Equal. It was about the Kipling method for doing zero trust rule writing. So who, what, when, where, why, and how. We got that from a guy named Rudyard Kipling. He created the Jungle Book. I was with a millennial. They go, oh, it's so cool that you're referencing a comic book author. And I'm like, oh, man. There's like a whole generation of English professors who are going to come out of their graves to haunt you. But when we look at who, what, when, where, why, and how, we see that who is an access control statement. The asserted identity, who is accessing a resource. What is an access control statement? By what application are they accessing that resource? When is an access control statement? Hey, when are they doing that? There's a lot of rules that you should turn off when people typically don't use them. When we look at attack traffic, we see our people left for the day, and here comes that foreign government, and they came on board. Oh, they took their coffee break. Oh, they're back. Oh, they took their lunch break, and it goes on and on. Turn off rules that aren't typically being accessed during certain times of the day. Then where? What is the location of the resource? And then why? What is the classification? How toxic is the data? How sensitive is the system? And then how? That's where we're inspecting the traffic all the way through layer 7 to do threat inspection or to do wildfire, DNS security, URL filtering. Those are all how statements. And then ultimately, we tie in via APIs in this larger ecosystem to help you understand which data you should dispose of. About 80% of the data that you have is what we call stale. No one has looked at it in the past 2 years. You need to archive off your stale data because the people who get value from that are the attackers who are going to steal it. And then finally, we kill or abstract that data, right? Encrypt, tokenize, mask. That stuff is your friend. And you need to understand how to do that at the binary data stream level, not just inside of a tunnel. So when I map this to what's called the Kipling method, we can see our 3 core technologies that are inside of PAN-OS. They are still, to this day, even though they're 12 years old, they are fundamentally profound and getting more profound every single day. If somebody else invented this yesterday, you'd want it tomorrow. And you need to understand that our user ID technology, which is a layer 7 instantiation of that asserted user identity, is really profound. That defines the who statement in policy. And then our application ID, we have over 2,800 known app IDs. And those things help you understand how to really reduce your policy statement and get it more refined. You saw Lee show you how to do that on stage and how to take HTTP, HTTPS, those 339, I think he said, applications using it, and drop it down to specific rules for just a few different applications. And then we have, of course, our content ID, a how statement. How, by what criteria should this rule be allowed or this access be allowed to happen? So this is where we have threat protection and SSL decryption and wildfire and DNS filtering and DLP and all of the things that we automate as a service inside of a particular policy statement. So using this Kipling method, I can teach anyone how to write layer 7 zero trust firewall policy. I did this with the CFO of one of the world's largest companies in London. Taught him how to write the policy statement for the application he cared about, the financial application. That's an app ID, right? So that's all we need to know. What application do you want us to protect? And then he told us the who's. Who does he want to have access to that application and ultimately the data behind it. And then out of that, we can infer what content ID we need to turn on in policies. So if we're going to the cloud, here's one for Salesforce. If the user ID is Salesforce, or sales, right? So we grab OUs from Active Directory that are salespeople, sales admins, sales managers. And as people get added in and out of AD, the rule automatically updates. How cool is that? And then we can add other authentication types. We can add multi-factor authentication. We can get more context. Eve's going to talk about this in a second. And this works for any application. Here's the Salesforce application. It's one of those 2,800 known application IDs that we have. So you can only access, if you are in that group using that application, then you can go there if you meet the criteria, the content ID. So salesforce.com content ID. And in this case, for example, we wouldn't turn on URL filtering because that rule will never be allowed to traverse the public internet. But we will turn on wildfire and DLP to make sure we can see if any data is leaking and is inappropriately going, or we can look for, say, PDFs going back and forth that might have malicious content embedded in it. So we can infer that content ID. And we can do this going to the cloud, or we can do it on-prem using all of our platform. And this allows you to really refine your policy and reduce your policy space. Again, we see that policy reduced 10 times. I see that all the time, because I used to be a firewall admin. I've deployed all kinds of firewalls. And you get those long lists of sequential rules in there. And what are we trying to do with that? No one knows. With Zero Trust, we can really make specific policy statements. So this is the definitive statement for today. Multi-factor authentication is not Zero Trust. It is, in fact, an attribute we use to validate authentication, and authentication is therefore consumed by user ID to create granular policy. That's what we're trying to accomplish. So how do we do this in a different way? Well, we have lots of ways to ingest user ID information. And we're going to be talking about it in a minute. But let's look at identity in a whole different light today. Okay? That's why I brought on Eve. Eve is going to talk to you about identity in a completely unique fashion so that you can understand how you can then get context and just change the way you're building policy and doing security.
Well, thanks, John. So I appreciate the opportunity to speak with you today. It's always fun working with John. Can you guys hear me all right? So we had a chance to work together at Forrester, where I worked on Zero Trust identity, stealing directly from John. So here I am at ForgeRock, working on identity and access management in kind of some unique ways. And so user identity context, has always provided input to these important decision-making points. And traditionally, what happens is you have somebody want to come in through the front door, they knock, and then you apply some policy to let them in. But we're finding some challenges with that now. One of the things I deal with really heavily, something ForgeRock does really heavily, is consumer use cases. I want just a show of hands for folks who deal with kind of consumer scale use cases: retail, government, government to citizen, healthcare, banking. This is something we do pretty heavily when it comes to user populations, the tens of millions, the hundreds of millions, maybe users in those devices. Okay, so, and one of the things you find in these cases is, so you're looking always for the upside for the legitimate users. And you're looking for, I don't know, there was a time I spent actually at PayPal, and the authentication flows they did there were part of a profit center. So you had to do fraud detection, and you actually had to measure how much money you were losing versus gaining, which is quite interesting. So when it comes to that, your MFA burdens sort of become part of this equation. And depending on how high the value of the asset, you're constantly measuring, well, depending on the length of your session, you're getting kind of far in terms of the distance in time from the value of your asset. That front door looks really far away. So you let somebody in, and there you are serving your really high value pu-erh tea to somebody who's gone rogue. There's that rabbit there looking kind of suspicious. So what you need to do is cycle faster and get more and better input signals around authentication so you can get finer grained authorization decisioning in order to get closer to your bad guys around all your assets of whatever value and closer to your good guys, in fact. Okay, so what can we do about those signals? I want to focus for a bit on those signals and getting more and better of them. So on the one hand, on the left side here, we have, let's just call them identity signals. Now these are uniquely identifying. We've had password for a long time, but obviously there's a whole plethora of things that are uniquely identifying now along the lines of two-factor authentication, what people out in the wild, people, non-tech people think of as two-step verification now. Anybody do any like open banking or things like that out there? Okay, so the regulations call those SCA, strong customer authentication, and they're mandated, okay? Now on the right, we've got what we've called non-identity signals. These are the heuristic signals, things like, device identity, things that I'm gonna call circumstantial evidence, that you can attach to a user for a time. How can you start to integrate these as business as usual? How can you start to reduce the friction to actually counting these as part of your cycle time? Pulling them in through cloud and API sources. So
and Nikesh today, if you were in his session, he talked about being on the same floor as Bibi Netanyahu at Davos. And he's 5 rooms back, and he has a meeting scheduled. But when he leaves his room, he has to still come out, go through security each time, right? This is what we're talking about, the time between there, right? Because if Nikesh was really a bad guy, malicious, he could have come into his room where somebody had stored a gun. He comes out, has his meeting the next morning with Bibi, and shoots him. This is what we're trying to, in the real world, in the physical world, security people have figured that out. We haven't figured that out. We got to have, you can't just authenticate once and then not look at it again through the entire life cycle.
It's distance from the asset in space and in time, actually, and then reducing friction both for users and, frankly, employees are people too, and you're preventing them from doing business if you're adding friction to them, and you need to reduce friction for the people who have to implement this as well. So you want to make the right thing to do be the easy thing to do. So what I want to talk to you about is an intelligent authentication architecture that actually has a way to add branching trees of logic. And so what I'm showing you here is nodes that can be added literally to these branching trees of logic that is event-driven. That trees, we call these authentication nodes, but in fact, you can apply it to registration logic. You can apply it to proofing and verification of identity logic. You can apply it to onboarding of a device. And so the idea is that it's flexible and you can design journeys with it. So, so I want to show, this is actually an example of a particular journey that an admin might design if, first of all, they want to decide if somebody presenting themselves with a credential is a bot or a human. So you can actually apply a Google reCAPTCHA bot analysis. And if you've established through that somebody is a human, well, the next decision point is, well, are they known to you or are they unknown? And you can decide after that point if you actually recognize them. Then you can go on from there. If you don't recognize them, you can put them through a registration flow. Okay? And then continuing from that point, showing the continuing part of this journey, at that point, you could say, well, what about the device that they're on? Is that previously known to you, or is that unknown? So you can now proceed with an initial user identity test that's a little bit tougher with MFA. And then you can also do a lot of context capture on the device itself. So here you're seeing user agent, location, IP address, browser, OS, all the things that you'd like to collect on which you can do some longitudinal analysis.
And you get that automatically from the HIPS profile inside of the Global Protect agent. So that's one of the things you need to understand about Global Protect / Aperture access, or Prisma access, is that we can ingest that stuff automatically. So now you have content of all these non-identity signals to start creating this journey. So you can see that authentication is just not getting in the front door. Now you have to think about authenticating a journey.
Absolutely. And now it starts getting really interesting because we've done some initial decision points with signals that we've gathered. And now comes kind of the biggest decision point. We're going from kind of a black and white, coarse-grained decision to the opportunity to do some fine-grained decisioning. And I've got this box here. Hopefully that's not too gray for you to read it. But you have the opportunity, and here's where we could call out via API to Palo Alto Networks Segmentation Gateway to make these decisions. It's no longer just allow versus deny, which in the case of, I'm thinking, some group that owns authentication journeys and has their own P&L responsibility, maybe what you do is you say, well, there's some non-uniquely identifying heuristic data that we got, circumstantial evidence, that for a purchase of this size, maybe I'm suspicious that there's some bot activity here. But it's a low purchase size, so I think what I want to do is maybe let it go through, but redact some of the data they're getting. So you're basically choosing to be a honeypot, you're choosing to do something different, you're choosing to rate limit, you're choosing to do something else. You're being more sophisticated about your activities. So moving along here, I want to show you some specific use cases that we're treating here. So here, you're the administrator actually building these flows, and so it's a little bit animated here. So admins want design palettes that they can choose from. They don't want to have to code this kind of thing. Since the login journey is the entry point for anybody into doing anything, there's rarely anything valuable they can do sort of from a public interface. You want to take all the ranges of signals and decisions and assemble them. So the flow controls become critical. In this case, you actually want to allow user choice. So this is likely a consumer journey here. And I think of this actually as your end user becoming a partner in the security of their interaction with you. And I'm sure you guys have experienced this yourself. And so this is actually providing a branching flow for somebody getting to choose to add 2FA and to choose the method according to what's available to them in a particular situation, because not every situation affords a particular method. This next one is the end user's experience of what it looks like for them to actually choose the method.
And for those of you who are on the consumer side, right, sometimes we only think of identity on our internal users, but all of our external users are identities as well. And so now you start to kind of commingle all that stuff, and how do you add context to it? That's what Eve is really showing you on how you get context, because again, all this data now can be consumed inside Cortex so that we can now really, really understand what's happening either on the internal side, the B2B side, or the B2C side.
So there's another interesting one coming up here where you want to be protected but not have your journey interrupted unnecessarily. So this is where it cuts really fine, where you want to have your illegitimate users detected and your legitimate users have a good experience, and you want to have some choice about how you respond. So in this case, you've got, based on a heuristic like threat intelligence, you want to be able to tag your session dynamically with some of this heuristic information. In this case, the malware check is a pass, but the have I been pwned is a fail. So this could cause a password reset, but maybe no other sort of adverse action. And here's another use case where you're a security architect and you want to actually capture and store all this environmental context. So this is done sort of natively, but as John just pointed out, we can call out to a third-party platform like Palo Alto and do that with the full capabilities of that platform. So let's see, I've got another use case here. So this is how you do, unfortunately, this Simon platform just went away, but we actually, we've integrated with the Have I Been Pwned API as well.
So are you guys familiar with Have I Been Pwned? Right, the database that you can look that up. Well, imagine being able to call that up in policy and use that as part of threat intelligence. Now we're starting to get this contextual level. And this is really important because there's this other word that you hear talking about, Nikesh mentioned it on stage, privacy, right, or privacy. If you're from the continent.
I've been forcing them to just say privacy, actually. It's working quite well.
And we are all going to have to deal with new privacy regulations, new ways to think about it. The CPPA, which is kind of crazy, GDPR. All of our companies have to deal with all of these things because we have global users, right? And so now, how do I start to deal with privacy information? And that's much more than just front door authentication determination. Now I got to figure out how I use all of that authenticated data in the right way, and then how do I know whether people are using that same data in a malicious way. These are big privacy implications, and you can have security without privacy, but you cannot have real privacy without security because it takes this kind of tooling to actually enforce privacy mandates.
Yeah, absolutely. Actually, one of the things we've integrated with is the Panopticon from EFF, if you want to actually look for a fingerprint of your browser. So who here is familiar with the WebAuthn and FIDO2 work? This is really interesting standardization of authentication work. So FIDO is, it's a standards.org, and they contributed some of their key work to the World Wide Web Consortium. And that has enabled this WebAuthn plus FIDO2 standard to actually get to the point where the major browsers now support browser-to-hardware strong authentication. And Twitter just announced, I saw on May 30th, that they're supporting this WebAuthn FIDO2 strong authentication as a choice. So if you use Twitter and you've turned on 2FA and you were, in the advanced guard on that, you can now actually go use one of the WebAuthn-enabled security keys, like YubiKey or the Google Blue Titan. So this is really major, actually. We've started to get, what FIDO has been going for is a passwordless world. We can maybe talk over a beer about whether we think that's possible, whether static shared secrets are possible to actually eliminate from the world. But this is a good thing any way you slice it. So being able to call out to a no-code, easy rollout method for integrating a strong authentication mechanism, it's amazing. I mean, this has been really popular.
And it brings up a question, right? Because I hear a lot of people, well, we want to get rid of passwords, and I'm not a person who thinks that that's either A, possible, or B, wise. But let's talk about it. How many people use their fingerprint reader on their device to authenticate? Or facial recognition, right? So, in the OPM breach, 2.5 million fingerprints were stolen, digital representations of fingerprints. That's not real fingerprints. No one uses your real fingerprint. They use a digital representation. So here's a problem, right? You go, oh, well, so-and-so's, Eve, your fingerprints were stolen. We're going to have to revoke your fingerprints and reissue you new ones.
Damn it.
Your face was stolen. We're going to have to give you a facelift. Well, for me, as an old guy, that might not be bad. But think about it, right? And think about the consequences when you go through the airport. Somebody can actually take your fingerprint and swipe your phone and make you unlock your phone. But you don't have to legally tell them your password. So we're given a short shift to static shared key, or static keys, or static
shared secrets.
Shared secrets, thank you. And we need to understand that there's value in some of this stuff. We need to have more context, but we don't have to reinvent the wheel.
That's right. Making the right thing to do be the easy thing to do is a really great path to success. And as has been said by various people, a lot of biometrics make a better username than a password. So there's the over a beer conversation in a nutshell. So let me sort of switch topics a little bit here. There's a notion of the extended enterprise. I'm using maybe As the World Turns as a good soap opera to hang this discussion off of here. Anybody ever watch As the World Turns, Guiding Light? I don't know, going way back here.
None of this crowd is going to admit to it anyway.
Yeah.
So.
I just gave a talk at this Munich identity conference, and one Dutch guy raised his hand. I'm like, you? Okay, you never know. But so...
Game of Thrones, that's a soap opera.
Yeah, that is true. Although, yeah, all right, there you go. So, we thought that, I've been in identity and access management for close to 20 years now. And we thought that enterprise IAM was a soap opera. You're talking 10,000 employees, 100,000 employees, Active Directory. That's your employee base. We thought that had all of its twists and turns, but it turns out it's relatively static and non-volatile, even with, role explosion and the rest of it. But there's a whole other story out there. And so what does that mean to us? So, you've got the greater employee population of partners. You've got customers and, consumers and all these other end users that you've got to watch out for. And the challenge with them is that, you can't make them do things. You're not the boss of them. In fact, if they want to use the insecure device on networks you care about, you can't tell them to stop. You have to gracefully degrade in a whole bunch of circumstances. And then you've got the challenge of all these other things with identities that you have to manage too, and the relationships with all these other users. And so in terms of identity and access management land, here's how we begun to think of these things. You've got enterprise IAM, which is, believe me, the easy case. The harder case is what has become called in my industry CIAM, consumer or customer IAM. And some of the tools are actually different, and they have to scale way higher. And it's much more volatile and much more, we don't have a choice. And then we've got what has started to become called identity relationship management, where you start looking at tools like graph databases just to manage the volatility and the dynamism of the challenge. So, how do you achieve zero trust in this environment? You have to actually start looking at some of the standards that actually I've been involved in creating and the care and feeding of to deal with this. So one of the key things that actually, it's not that new, that is available to us to solve these challenges is the OAuth standard. So in a nutshell, OAuth enables us to delegate access to applications without having to give away passwords to third-party apps to the first-party service. And, I used to joke back when I was, an analyst that you couldn't get fired for protecting your API with OAuth, but I still think it's actually not true today. So if you need to go back and justify usage of OAuth versus API keys, I wanted to give you the quick reference guide to why you should be using OAuth, okay? Client applications do not store third-party service passwords. You can leverage any user authentication method, including good, strong ones like the ones we've got in 2019. You can actually grant least privilege access to API features. And you can actually track and revoke access per client application. And so it even gets better, and this is one that I still find today people don't have an appreciation of in the GDPR era, in the California Consumer Privacy Act era. You can actually capture user consent for access. And for the one or two people who said, I do open banking, you can see some of that come into play because they've got OAuth-based flows. because people know about OAuth, there's SDKs for it, you can lower the cost of secure app development. And it turns out that OAuth has been extremely generative for a variety of different standards, sectoral and horizontal, financial, healthcare, a whole bunch of other flows in other areas.
And remember today, in Lee Claridge's keynote, he talked about how many people have APIs, public APIs exposed to the public internet, right? So this is going to be a bigger thing. This world is API driven. API is the glue that keep everything together. And so how you protect it is going to be super important.
Frankly, we only have an IoT economy today because we have an API economy. We had M2M for a long time where they had the whole, chewy in the center and crunchy on the outside. And IoT security is still a disaster today, partly because they haven't cottoned onto this. So beware and be wise. We also have, we have standards for identity, and SAML's the oldest one. And sometimes I apologize to people when I say, yes, I was involved in SAML. It was built on top of XML, and okay, I can apologize for that too, but hey, some things still work. And now there's OpenID Connect, which is built on top of OAuth. And this is just a very brief accounting of what the two of them do. One of the things I think people aren't fully aware of, if they need a comparison between them, is that SAML specializes in two different flows, which is you can start from your provider of the identity and move on. That is, the user can start from the identity provider and move on to the relying party, the service provider that needs the authentication information. OpenID Connect is strong when it comes to using mobile applications, which SAML isn't, but it only does the flow where you start from the service provider that needs the authentication information coming from the identity provider. So it's way more modern. It uses JSON. I'm a big fan of JSON. So that's just a quick kind of rundown of the two of them. One of them is older, but...
And I see a lot of people still struggling just to get SAMLized federation, right? But if you're struggling with that, just move on. Move on to OAuth or something built on OAuth, OpenID Connect, because now you can do more stuff with that identity information. You can have more context, more granular control, right? So it's not just about single sign-on anymore. Identity isn't Active Directory plus MFA plus single sign-on. It's much more than that, and that's the message, right? And you won't get that message anywhere else because other people in cybersecurity don't want to admit the complexities of identity. And they don't have user ID, which can consume all that stuff and pull it together into a single entity profile that you can use in policy automatically once you have the back end figured out. And this is going to be so important in microservices, in cloud architectures. It's going to be amazing. I think in a year from now, you're going to be going, oh, I'm glad I came to this session because it made me think about identity in a completely different way.
I'm not finding new strategic security flows being built on SAML today. I am finding new strategic flows built on top of OpenID Connect today. And I wanted to mention one other standard that is relevant. It's not as much used, but I think it is relevant because, John talked about, well, sources of user ID. For the enterprise, it's going to be AD, but where some of those identities come from, if you're looking at that, what I call the greater employee population partners, even for consumer identity populations, it could be bulk loaded from a standardized API called SCIM. And all these things build on top of each other. So it's a standardized API. This is kind of their architecture in pictures. Well, SCIM is an API. How is SCIM protected? Typically with OAuth. Sometimes, actually, with a standard called UMA. And John mentioned it briefly. UMA is user-managed access. And I'm aware of at least some cases where that's used in an API access management fashion. And that's basically a party-to-party delegated authorization standard that itself is based on OAuth. So that's kind of a quick tour around how you get identity across domains in this extended enterprise milieu that we find ourselves in.
And there's going to be so many use cases. I mean, let's think about, we've talked about the internal use case, right? We have our own internal people. And then we have clients, customers that have to have access, so that's another use case. And then think about doing cross-domain authentication when you do an acquisition or something like that, right?
Yep.
How do you deal with that? We can't solve all this stuff at the directory level. And we try. We used to have a joke at Forrester that Active Directory wasn't the solution, it was the problem, right? So Active Directory is good at what it does, which is storing a username kind of combo thing, right? It was originally designed to store X509 certificates. That's what LDAP was for. But we've then tried to turn it into something much more than it can ever actually do. So now you're going to have to think about identity beyond Active Directory, identity beyond MFA, and identity beyond SAML. And then how do you actually enforce that contextually in real time as asserted identities access particular data? That's what Zero Trust does. That's how identity works inside Zero Trust.
And a final thought on this before we make some concluding remarks here is that being able to source identity from its authoritative source is itself a Zero Trust way of thinking, because if you're not authoritative and you've got some sort of delegated admin pattern that you're using, you've basically cut off yourself from the authority of the information, and you've basically made a copy. So if you're aggregating information, you now don't know, like, what are the steps you have to go through? How many steps do you have to go through to deprovision somebody from another company, and that resides in your AD? It's much more suspicious than if you actually have them connect in a more direct fashion, where there's only one copy of that information. So with that, this is meant to represent the fact that we need the highest quality input signals in order to have the appropriately fine-grained decisioning. Oh, delicious. It looks so delicious there, doesn't it? Authenticated identity is the key set of input signals that we need for determining whether somebody's authorized, right? And all the other input signals that we've talked about, all the other sort of non-unique identity, heuristic or circumstantial evidence, as I was calling it, input signals, are key as well. And we need them as close in space and time as possible to our assets of whatever value. So what I've tried to show in my portion of this is that an adaptive and incremental approach can be added no matter what kind of user you're talking about, in fact. And it can be valuable to reduce friction for the legit users, and that enables a policy engine to do its finest stuff.
So as people who interact with Palo Alto Networks technology on a day-to-day basis, right, as you go back and talk to your identity people, because that's often a different set of folks in an organization from the cybersecurity people, understand that identity and cybersecurity have to tie together, and ultimately identity and Zero Trust go hand in hand. Eve says they're chocolate and peanut butter, right? We make each other better. And so having that contextual ability to take these identity signals and non-identity signals and tie them together and then have fine-grained, granular control in policy that changes as the context changes in real time so that you can automate that. That's what we're actually trying to accomplish, right? We're trying to get it so that you can take all of this inputs and we will automate the output, which is you can either get access to this in this way, or you can get access to this in that way, or you can't get access to it at all and send you an alert. And there shouldn't be, ultimately, human beings involved in that decision. We have to take all of this rich data, bring it together so that we can automate it so that you guys can do more important jobs than just deciding who gets access.
Absolutely. So, and our companies are actively working to figure out new ways to combine all this stuff. So hopefully more information for you about that anon. And with that, we can just...
Yeah, so bottom line, Zero Trust is not MFA. If you could take anything away from it, it's not MFA. The MFA people have learned how to take a pretty boring and commoditized technology and sell you it in a way that will ultimately disappoint you because it won't give you a zero trust environment. So,
especially as it gets standardized.
yeah, we're in a brand new world. So go back to your IAM people and start talking about identity in a different way and figure out how you can consume identity in policy to build zero trust policies so that you can enforce and protect your companies and prevent data breaches and successful cyber attacks. So thank you very much for coming. Thank you for being a customer. Enjoy the rest of the show.